Well, hello everyone. It's about 3 minutes past 1, so I'm going to kick this thing off and get this going. My name is Michael McCarty. I'm from Edge Fall Protection. So we're design, we procure, and we install fall protection systems in all 50 states. So if you do have any other questions, either you have a specific scenario that you want to address, we can address that in the questions afterwards, or you can reach out to me later. The QR code in the bottom right-hand corner, bottom left-hand corner, pardon me, is available to connect with me if you do have questions. And hopefully I can steer you in the right direction. A few logistical items I just want to cover. This course is being offered for AIA Learning Credits, American Institute of Architects. So if you do want to get credit for this class, we're happy to give that to you. Just drop your number in the chat or follow up with me afterwards. You will get a follow-up email. So just put your AIA number. I'll make sure you get credit there. One other thing, if you hit the select, or pardon me, the more icon, you should have a Q&A tab. So if you do want to ask questions, we'll get to those questions towards the end. It always makes it a little better if people have some participation throughout the course. And then finally, we'll be doing some poll questions kind of throughout this whole webinar. So if you have participate in that poll, if you'd like to do that, I know we'll be mailing out a couple t-shirts towards the end if you get them all right. So good luck, go get them, and we'll get this thing kicked off. So again, Michael McCarty, Edge Fall Protection. So we're based in Minnesota. We're in all 50 states. The things that we'll be covering today, we're going to start off with agendas, just kind of get a base, a foundation of what fall protection is and kind of the vernacular that we use. We'll be talking about the hierarchy of fall protection and the ABCs of fall protection. These, again, are very fundamental of how to look and apply fall protection concepts in the workplace. We'll be talking about an update to OSHA 1910 and 1926. Those are the two standards that dictate what kind of fall protection you use in different environments. We'll be talking about OSHA versus IBC. There's a ton of confusion between when do I need fall protection on a rooftop. So I'll address that. We'll talk about specific rooftop hazards, what you should be on the lookout for, either when you're designing, planning, installing, or protecting your employees. We'll look at the pros and cons of a penetrating versus non-penetrating fall protection system. And then we'll just briefly cover the inspection requirements and testing certifications. Again, any questions on any of these things, strap it in the Q&A. We'll definitely touch base with it towards the end. So kicking off with OSHA definitions. There are really three types of people that we talk about when talking about fall protection. It's an authorized person, a competent person, and a qualified person. An authorized person is going to be an employee who's assigned or approved by their employer to use fall protection. So you would come to work at Edge. We would show you how to put on your harness, use your lanyard, connect to an anchor, properly be aware of fall protection. It's a smaller kind of training, 4 to 8 hours of these are the fundamentals of fall protection, how you use the systems, and which systems you're allowed to use. So pretty specific for people in the field. A competent person, so we generally have a few of these on site on our install team, but these people are authorized to identify and correct fall hazards in the workplace. So they've had a little more formalized training than your general authorized person, and they've undergone probably some sort of class. We send our people externally, so they learn internally, but they get some good input from other sources as well. And then you have a qualified person. So a qualified person is a person in possession of a degree, a certificate, or professional standing that can identify or solve problems related to fall protection. Professional engineer, any sort of certified safety professional, someone that can look at a scenario, design an entire system. That means how does it connect to the structure, or what are the foundations in place, what kind of SRL lanyard connector we're using, what type of harness, and then they're going to be calculating free fall distance as well, which is a very important part of any certified fall protection system. Next, moving on to the hierarchy of fall protection and the ABCDs of fall protection. So these really parallel each other quite a bit. So I'll be kind of skipping back and forth on them. Hierarchy of fall protection. So this gets its name from Maslow's hierarchy of fall protection, also a pyramid. This one's upside down, but it still works. And we want to conceptualize this as the most effective way to use fall protection and the least effective way of using fall protection. It's really important when you're thinking about things, especially in the planning phase, to use this hierarchy. And then in the field, if you're doing any work in the field, how can I use this hierarchy of fall protection? Because people generally skip a couple steps. First, we're going to talk about eliminating hazard. So if at all possible, we want to not use fall protection at all. So a couple examples here. You have a rooftop unit on your roof that you need to service monthly, twice a month. So instead of maybe servicing that unit, you could bring that unit to the ground floor if you have space for that. And then you don't have to have anyone get up on the roof at all. I was in a facility a few weeks ago that was kind of a petrochemical location. They had valves that required shutoffs. They were 30 feet up in the air that we needed to install some fall. Is definitely going to prevent someone from falling. So eliminating the hazard, number one, can we design it out? Can we eliminate this entirely? Number two is passive fall protection. This is the one that Edge uses the most. Passive fall protection is railing. It's stationary prevention. It is non-dynamic. You don't have to train anyone to use it. It's always in place. You don't have to really recertify guardrail systems. It's an exceptional way to use fall protection because it's always there. These next two, fall restraint and fall arrest. Oh, can you guys hear me okay? Okay, great. All right, it's working again. I am sorry if I lost you for a second there. Maybe cut out for 30 seconds or a minute. But I was talking about passive fall protection. That's guardrail. If you missed that, it's a really great form of fall protection. It's always in place. Restraint and arrest. These are considered active fall protection. So eliminate passive fall protection, active fall protection, two components there, restraint and arrest. Any type of active fall protection is going to involve your ABCs. So it's an anchor, it's the connector, and the body wear. Again, we'll go into detail in a few slides here. But fall restraint isolates people from the hazard. So it's effectively a dog leash. If you think about a worker up on a rooftop and you have an anchor point that's 15 feet away from the edge, I would give that person a 13-foot lanyard or a 14-foot lanyard. That person cannot go over the edge. So it's isolating the hazard by not allowing them to go over the leading edge. That's fall restraint, dog leash concept there. Fall arrest is when we stop a fall if one should occur. So that same example, anchor point 15 feet, and then you have a 20-foot SRL. So now the user can walk off the edge, he or she can trip or fall off the edge. And then that fall protection system is going to be designed to ensure that if that person goes over the edge, he or she is caught before they hit the ground. And then the least effective administrative controls. So this is team warning, communication. It is a company saying, hey, you can't go within 15 feet of the roof edge, sign your name here. So I verbally told you there's not a lot of teeth. There's very little training generally. Um, and again, hierarchy, most effective to least effective. We want to think about eliminating the hazard. We want to try to use guardrail as much as possible. If we can't do that, people often skip fall restraint and go straight to fall arrest. But restraint is much better. You don't really need a fall protection plan if someone can't get over the edge. So next up, we have ABCDs of fall protection. So the A stands for anchor. There's there's really two types of ways to design an anchor. We have a non-certified or improvised anchor. Those are tested. Those have to meet a 5,000-pound load test. And then we have a certified or an engineered anchor. So this is something that qualified person, the terms that we talked about in the beginning of the presentation, that a qualified person can analyze a structure, a scenario, and say, this is your anchor, this is your cable, this is your lanyard, this is your harness. The max arresting force, the MAF, exerted onto the structure is going to be 1,800 pounds. So now that 1,800 pounds needs to be multiplied by 2. That's 3,600 pounds. So that's what we would design that anchor for now. So 5,000 pounds, you'll hear it a lot in the industry. That anchor has to be 5,000 pounds. That anchor has to be 5,000 pounds. Yes, the anchors are generally tested for 5,000 pounds by the manufacturer, but if it's designed by a certified professional or an engineer, we can do that 2-to-1 safety factor. That can have a big impact on the designing loads and the designing requirements of that anchor if we're doing 3,600 pounds as opposed to 5,000 pounds. So, non-certified improvised, that 5,000 pounds. So this is people in the field saying, yes, I can tie off to that beam, I can tie off to that structure. What weighs 5,000 pounds? A rhinoceros, or one block from the pyramids of Giza. So if you can conceptualize a rhinoceros, if you've ever seen one, I think it's a more fun concept than hanging a truck or something like that. Things that are going to go into play here on design and anchor. What kind of substrates are we attaching to? Steel, concrete, wood. These can really change how that anchor is designed. So going into the B's of ABCs, we have body wear. So your harness. We have examples of the full body harness. Almost every time you should be seeing the dorsal D-ring. That's the fall arrest icon on the furthest right-hand side. So that dorsal D-ring should be standard. Excuse me. There can be access limitations. The chest D-ring, you'll see a lot more of those in the industry, and we'll talk a little more later about why these ladder climbing chest D-rings are becoming much more popular and much more prevalent. We have suspension a little below your hips. We have work positioning. Our guys use this a lot when we're installing vertical lifeline systems. So our employees can work hands-free and position themselves on a ladder, on some rebar, whatever it might be. Things to remember on body harnesses, body wear, is that they do need to be inspected before each use. So when an individual goes through that authorized user training, that person should be trained on these are the indications of when to take a harness out of service. So the stitching is torn. Each harness has impact indicators. So make sure that those are not pulled out. There's no rust on the D-ring. Kind of self-explanatory things, but important to just train and go over. It should also be inspected at least annually by a qualified person. We do it twice a year because we use ours quite a bit. So depending on use, you might want to use them more if it's in a really corrosive environment. Inspect them more often in a corrosive environment. And ultimately, whoever's wearing it needs to be comfortable, and they need to use them. So if the harness is not comfortable, they won't use it. And if it becomes a big challenge, they're less likely for them to use this properly and effectively. One other thing about harnesses, they do need to be 100% on. Make sure that all the buckles are clipped together. If this is part of a whole system, so if one component of a harness fails, the whole system can fail. So really important that everything's put on correctly. The C's of the ABCDs, that's your connector. So there's a lot of different names for the connector, but what it is you have your person wearing your body harness. That's the B. You have your A, your anchorage, and the C is the connector. It's connecting your harness to the anchor point. Lanyards, lifelines, SRLs, these are all words for a connector. Depending on the use and the application, you're going to pick a different one. There are so many of these available on the market. Sometimes it's a little nauseating, honestly, to find the right thing for your specific environment when you're designing a system. But it's worth the effort because, again, one component of this failing, the whole system fails. So, just the example on your screen right now, the fault clearance table. So we designed a horizontal lifeline overhead for these people working on this conveyance. And in order to design this system has deflection, and it has a SRL and a lanyard that reduced free fall as much as possible. All of these things have a certain amount of payout, a certain amount of free fall. So this system was designed and the fall clearance table was done. You'll see that the user only has a couple inches between the floor and their feet. So it's very important because if we gave this person a different SRL than what we did, they would have hit the floor entirely. Funny story about this picture actually specifically is that we field verified these dimensions. They were inaccurate. We had to switch to a different system entirely because we didn't have the ground clearance that we needed for the user. The D of fall protection, descent rescue. So these are things that you're really going to have to think about only when you're using the active fall protection system. But it's very important to consider this, to think about this. The communication between the fallen user needs to be prompt. The communication should be less than 4 minutes. As much as possible, we want to keep this simple. And calling 911 is not a fall protection rescue plan. So other things that we can use, simple devices, ladders, boom lift, mechanical advantage, setting up a 3-to-1 mechanical advantage or a 5-to-1 mechanical advantage takes time. And if you don't have the skills to do it, it does you absolutely no good. Those are our guys in our shop practicing a self-rescue. So they use a rope with an ascender, and they kind of inchworm their way back up the rope after we pull one down. But this system does no good if the person is unconscious. So a lot of things that you need to consider when thinking about the fall protection plan. Practice, practice, practice is going to be the most important thing. So whatever you do, make sure that everyone knows how to do it properly and can do it under a stressful environment. Talking next about OSHA updates. This is OSHA updates subpart D. So this was updated in 2018. These standards, the 1910 and 1926, I think, didn't get an update for about 50 years prior to 2018. So they were due for an update. What changed in it? I'm just going to cover kind of the biggest things that impact roof safety. There was a lot of miscommunication or non-clear standards about when do you need fall protection up on the rooftop. They cleared that up and said anytime you're within 15 feet of the leading edge performing work, you need to have fall protection. Pretty cut and simple, pretty plain and dry. The other big impact that we've seen is there are no more cages going on ladders. You guys have probably heard about this, I imagine, or at least somewhat aware of it. Prior to this rule, any ladder over 20 feet, there was a cage put on it. What they found out was these cages aren't keeping people safe. People are falling down still, and sometimes they're banging themselves up worse on the way down than had they just fallen. So what's going on now is we require some sort of fall protection system. OSHA requires some sort of fall protection system at any ladders that are over 24 feet. We have we have until 2036 to swap all these ladders out with some sort of personal fall arrest system there. Um, we get the question a lot. Hey, what do I have to do with my existing cage? Do I have to replace my whole ladder? No, you don't have to replace your existing cage. But you can have some issues with the cage adding some sort of structural integrity, so it can change the loads and the stress of that ladder. So just making sure that uh, we're doing some sort of design criteria and analysis on what the ladder will look like without the cage. Other thing there is the user does need to be able to ascend and descend the ladder easily within the cage, and that vertical lifeline is taking up some real estate in your cage area. So if you have a big gut, it makes it a little bit harder to climb the ladder within a cage and a vertical lifeline system. What kind of impact does OSHA expect from this? They think they'll reduce fatalities by about 29 per year, and they will reduce lost workday injuries, 5,842 lost day work injuries per year. So pretty substantial impact. It's going to be a big investment. This is a big change. A lot of companies have to invest a lot to do this. OSHA did determine that this investment, unfortunately, there's a price on every life, but this investment is going to save a lot of lives, and overall will save money, which is good. Fall statistics from 2022. So this is the most recent year that we have statistics from the Bureau of Labor Statistics. 5,486 fatal injuries in the workplace in that year. 865 fatal injuries from slips, trips, and falls. At 16%. It's the number one cause of workplace deaths in the construction industry. It's the number one most cited OSHA standard. It's fall protection training is the number 8 OSHA cited standard. It's 100% preventable. I mean, this is about 2 fatalities a day. So it's really a substantial problem that exists in the workplace. So what do we see building owners and employers doing from this subpart D? Well, number one, we're adding vertical lifelines or some sort of fall protection system on any ladders over 24 feet. We're adding a lot of vertical lifeline systems on ladders that are under 24 feet. Why would you do that? I think just simplicity of the workplace. We've installed a lot on ladders that are 10, 11, 12 feet because a facility might have 50 ladders. They don't want the users to have to think about, is this a ladder where I need to put on my harness or not? They standardize everything and say, all ladders, we're using vertical lifeline systems or some sort of fall protection system to ascend and descend. So kind of a simplification there. We see much more perimeter guardrail systems. Again, passive fall protection is a really great way to go. You don't have to deal with all the complexities of training and using the systems. And then controlled access zones. So this used to be warning line, could be used at 6 foot when temporary and infrequent, and it's 15 feet currently, and that's permanent. So one of those solutions we offer, weighted base plates, it's up there permanently, it's not going anywhere, rain, wind, or shine. We put that permanent visual warning line system at 15 feet. A lot more rope descent systems, fall protection anchors to new and existing buildings, a lot more training. And we've seen a dramatic increase in the rope descent system anchor certification, which I'll talk briefly about at the end. Okay, so fall protection requirements, OSHA versus IBC. OSHA is the governing body, the federal governing body that says you have employees, you need to protect them. Here are the rules and regulations that you need to protect them. IBC is International Building Code. So this is making environments safe for the general populace. OSHA, again, really specific for workers. IBC is kind of for everyone. So the same standards should not apply because you have different training, You have limited access to where employees are working. Um, so the OSHA general industry standard is that any fall protection is required on heights above 4 feet. Loading docks, any type of roof application, all need fall protection. Loading docks are usually right around 46, 47, 48 inches. So they're right on the cusp there. When do we need fall protection? In OSHA, 0 to 15 feet of the leading edge and doing any work, fall protection is required. Doesn't matter what it is. It can be the guardrail. It can be a fall restraint system. It can be a fall arrest system, but there does need to be fall protection. Um, if you're over 15 feet, a visual warning line system that I talked about previously. IBC on the other hand, fall protection is required if the roof hatch or mechanical equipment is within 10 feet of the leading edge. So if you're an architect, you're designing a building, your roof hatch is 12 feet away from the edge. In order for the occupant to get their COO, their certificate of occupancy, they're going to look at the IBC and they're going to say, hey, this roof hatch is 12 feet away from the edge. You don't need to provide fall protection here. But if we look at that from an OSHA perspective and we're considering the end user who is going to occupy that building, who is going to have employees in that building, who's going to have access to that rooftop, that roof hatch at 12 feet is within that 15-foot range, and that should be protected by some sort of fall protection. That's the most common one I see, is roof hatches really close to the corner and within 10, 11, 12 feet. And it's a question of which standard do we need to adhere to. Slides were stuck for just a sec there. Let's cover rooftop hazards. So this is rooftop solutions here. So how do we prevent someone from hurting themselves while working on a rooftop? We got to identify the hazards first. So I think the most obvious one is any sort of leading edge, any perimeter on a rooftop. Again, a rooftop is almost always going to be over 4 feet. I'd say 99% of the time they're going to be over 4 feet. What if you have an elevation change? So you have buildings that are adjacent to one another, they're different heights, or you had an addition to your building at some point. If that elevation change, that a working surface is greater than 4 feet, that would be a leading edge. You would need to provide some sort of fall protection there. So there any unprotected side, again, they're pretty obvious. As I mentioned before, passive fall protection, great. Guardrail solutions. The picture in the back is our non-penetrating system. And then you'll see that it's 15 feet from the edge is when we start our visual warning line system there. Horizontal lifelines, great option as well. Anchor points, and again, visual warning line systems in the picture. The rooftop hazards, skylights. So this is a dome skylight screen. You see this probably most often. You see the dome skylights. They are seen as a whole to OSHA. So these aren't rated for fall protection. They can get covered in snow. They're exposed to, they're generally an acrylic, so they get exposed to sun and rain, and they just kind of deteriorate and make them a little more brittle. The dome skylights are more obvious. The ones that I think are especially dangerous are R panels. Skylights that are on R panels or corrugated roofs, standing seam roofs. These skylights are usually 24 or 36 inches wide by about 10 feet long. Sometimes they're 20 feet long. These skylights blend in with the roof walking working surface. So as they kind of deteriorate, people don't see them while they're walking on a roof. They call these the Widowmaker, not a great name. Again, difficult, sometimes impossible to see. I was at a project in New Mexico 2 months ago. They had two people fall through skylights on the same building in 1 year. And it was these types of flush mounted corrugated roof skylights. So make sure you're thinking of this. This is a whole, this is something that we need to protect. If we're doing work or if we're walking by these things at any time, let's get some fall protection around those. Other rooftop hazards, roof hatches. Again, you open that roof hatch, and oftentimes while I'm on roofs, people are not closing it while they walk around the roof. So putting some sort of guardrail system around the perimeter is super important because that is a hole. Other thing with roof hatches, as I mentioned in one of my previous examples, these things are almost always right by the corner of buildings. Um, so if they're within 15 feet of the edge, we need to have some sort of fall protection to make sure that once the person comes out of the roof hatch, they have something to tie off to, they have some guardrail around them to stay protected. These are the highest traffic. So ladders going up to the roof, ladders changing elevations. That's where people are accessing the roof. This is where accidents are going to happen most often. So if you have a priority on your rooftop, it's get a roof hatch guardrail around that roof hatch. We have a ton of different sizes depending on what you need, but really important. Other things I want to point out, yeah, sharp edges. If it's cold out, the flashing is going to be cold. If it's hot out, sometimes you put your hands on that and it burns. They can be slippery, difficult to maneuver. So really important. Again, put some fall protection around these, please. Other rooftop hazards, access and egress. So ladders, access ladders, so straight up and down ladders, ship's ladders at a slight incline, crossovers, ramps, any sort of stairways. Just be aware if you're in some sort of caustic environments, you're in a warehouse and there's some cold storage. You have ammonia lines up top. If something bad happens, there's an ammonia leak. You're going to have some sort of mustard point outside. And how fast can people get off of your roof and into a safe zone? Ladders are going to be more challenging than something like a stairway. And we've seen a lot of customers reach out to us and say, hey, we want to get rid of all of our ladders. We want to go with stairways because we're a cold storage facility. And when something bad happens, we got to get off that building immediately. So just being aware that in those emergency situations, people can get off the roof safely and as quickly as possible. Penetrating versus freestanding fall protection. We offer both of these systems. They both have their pros and cons. So what are you going to see with any sort of penetrating system? It's going to have some sort of analysis of the substrate. Again, is it wood? Is it a concrete? If it's concrete, what's the PSI? What's the thickness? What's the structure? If it's a steel deck, what's the gauge? So what are we dealing with? How do we attach to that roof deck, that substrate? What's the attachment method? We're almost always going to need to bring in a PE to make sure that we weld, fasten, drill correctly to the structure to make sure that our system maintains integrity. Anytime you're cutting a hole in your rooftop, you're going to open yourself up for potential leaks. You could void your rooftop warranty. And then the installation can be, it can require a hot work permit. There can just be more things involved. Generally with the fastened systems, the product is much less expensive. You do add more labor with the installation and you add more labor with the PE review, which can be challenging in and of itself, getting the right information. But a really great option for a lot of scenarios. We do a lot of freestanding systems as well. These are generally permanent solutions. The way that we provide them to customers, they're almost 90, I'd say probably about 90%, they're for permanent solutions. These are not generally going to make any penetrations. So there shouldn't be any leaks. There shouldn't be any issues to your rooftop warranty. Most of these are pre-engineered. Many of them, this is the picture that you see on there is our freestanding constant force post. So that's an anchor system. We can set up a horizontal lifeline with that as well. It's very heavy. So we do need to have some sort of analysis on the structure, make sure that we place these in the correct spots over joists or girders or whatever, to make sure that we're supporting it correctly. Installation is a little simpler. They do have their limitations though. Maybe there's a sliding factor that you need to consider on the base or the freestanding equipment. So if you have any questions on any of this stuff, either myself or someone from our team can always steer you in the right direction. Again, like what's best for your leading edges, what's best for your hazard. Just remember the hierarchy. If you can get rid of that work on your rooftop at heights, do that first. If you can't do that, add some guardrail. And if you can't add guardrail for whatever reason, let's get work restraint in there. And then we'll do fall arrest, pardon me. We really don't want to use administrative controls at all, unless we're eliminating access to an area entirely. And that's a pretty effective control. Moving on to inspection cadence, probably have about 5 minutes left. So if you guys do have questions, please drop them in. We'll get them answered. Inspection cadence for any sort of anchor or horizontal lifeline, or any sort of fall protection system in general. You're going to want to check it. So that authorized person is going to want to check their harness, check their anchor, check their connector, make sure they're all in good working order, every time. Again, every time. If it's for non-users, we do an annual inspection there. So you should have someone else or someone at your company should be trained to inspect this equipment once a year. You can always do third parties. We do it. A lot of engineering firms do it. So there's a lot of folks out there that can get that done. Just make sure it's done. If you do it yourself, you're just taking on some amount of liability. So just be aware of that. What do we test everything to? We test everything to 2,500 pounds. So that's informed by a couple different standards by ANSI, International Window Washers Association, Cal OSHA, and another ANSI. These need to be tested. So fall protection systems need to be tested every 5 years. Any rope descent systems need to be tested every 10 years. And that is it for the slide presentations. What kind of questions can I answer for folks?
Nice work, Michael. Yeah, looks like we got a few questions here. I will just start at the first one and kind of go through them. And people, feel free to add anything that may come up. So the first question we have here is from Ernest. He is asking, is a vertical lifeline system required for all ladders greater than 24 feet, or is it just fixed ladders?
Oh, that's a great question. Fixed ladders over 24 feet need a fall protection system.
Awesome. Next one here is from Arvin. Where is 10 feet usually measured from? Edge of the rooftop unit or edge of the clearance allowed for maintenance access? So I think it's kind of a rooftop fall protection question.
Yeah, that's a good clarification too. So if I understand it correctly, your unit's at 12 feet, but you need 3-foot clearance, 3-foot working clearance. That would be, pardon me, your unit's at 18 feet, but you need 3-foot working clearance. So that puts you at 15 feet. It's wherever the work is being performed. So if the work or the access to the work requires you to get within that 15-foot area, you should have some sort of fall protection. It is a gray area. OSHA intentionally leaves their rules and standards kind of vague so they can interpret these and enforce or change things as things change in the industry. Use your best judgment there. But I'd say anytime access or work is being performed within that 15 feet, have some sort of fall protection there.
Question from Dave. Let's see. Can you speak to the controlled zone, 6 feet versus 15 feet, and low sloped roof requirements? And what defines a low sloped roof?
Yeah, certainly. So low slope roof generally is a 112 pitch. So low slope or flat That's what you're going to see with that definition. And then as far as controlled zones, that 6 foot is temporary and infrequent. Pretty much the only people allowed to use that 6 foot zone is roofers or folks in the construction industry. But any type of general industry application is going to require that 15-foot offset. So if you're in the construction industry, that 6 foot probably applies. Temporary and frequent vinyl flagging. If you're in the general industry, 15 feet, a permanent visual warning line system.
Great. The next one here is, are swing gates required for all ladder entryways?
Yeah, another good question. It's an opening, it's a hole, it's a opportunity for you to fall through. So yeah, a self-closing safety gate should be provided at any sort of ladder transitions where a person is exposed to a fall.
Question from Cody. Is there a certain degree at which a ship's ladder would need a vertical lifeline? It's a good one.
That is a good one. I'll have to get back with you on that question. I don't know for certain the answer there. We do provide vertical lifeline systems on non-straight slopes. It's a different type of system that we use. But I will log that away, and I'm sure we have your contact information, so I'll follow up with you, get you an answer.
Yeah, there's a few questions here. I think Michael will have to reach out directly, but I'll keep cruising here.
Okay, thanks.
Question from Dave. When you're talking about infrequent use, does that mean if we install new equipment on a roof, can we use the 6 foot requirement?
Infrequent use. We ask that one more time for me, please.
Yeah, so I think they're talking about if they were installing a new piece of roof equipment, would that qualify as infrequent? So can they go with the 6
Got it.
foot?
Yes. I think that would be okay. Again, you need to set up your vinyl flagging at that 6 foot. It's pretty close to. I wonder how close the work is being performed to the edge there. Um, if you're performing work at 7, 8, 9 feet from the roof edge, I would put up some sort of temporary guardrail there and not lean on those visual warning lines. It's
Awesome.
really one slip, trip, or fall away from the edge.
Yeah, yeah. Let me read through some of these here. Question about ladders again here. Does OSHA require fall arrest on fixed ladders over 24 feet on new buildings now or not until 2036?
Yeah, that's a good question. Any new ladders, any new construction, um, should have a personal fault arrest system on any ladder over 24 feet. So if you're building a ladder today, it should have a vertical lifeline system. It should not have a cage on it. We have until 2036 to swap out the existing cages, and either swap out the cages or put a fall arrest system on the existing ladders with a cage.
Perfect. Yeah, we'll stick on the ladder train here. When hooking up to a vertical lifeline on a ladder, should a front center D-ring be used or the D-ring on the back of the harness?
Okay, great question. So vertical lifeline system, that would generally mean that the cable system is in front of you. That's not the only fault arrest system that we can use on a ladder, but if you're using a vertical lifeline system and it's in front of you when you climb, you should be using your chest D-ring. There are other options where we can put like a steel post, a steel galvanized post on your ladder or over the ladder. And then you could use an SRL block overhead, and then you could put a tagline on it and pull it down, clip it onto your dorsal D-ring. But again, using a vertical lifeline system does need to be that dorsal D-ring. You can't use an SRL to hook up to a vertical lifeline system. It's just not designed for a fall like that.
Awesome. Here is a good one here. how does a non-penetrating guardrail system stay in place without welding or drilling?
Oh, great question. Um, so our guardrail systems, I think it's in my background. So our bases are 104 pounds of cast iron with either powder coat or galvanized finish. The way that we design our system is our stanchions can't be more than 10 feet apart. And every time we begin and end a run, we have what's called outriggers, which is a kicker. So if you had a 20-foot run, you'd have a 20-foot section with two 5-foot kickers or outriggers coming into the roof. So that makes kind of a U shape. Um, because we provide that additional ballast there, and that's how the system function is really through ballast. It provides enough cantilever weight to ensure that our guardrail meets the 200-pound load test that it needs to per OSHA.
Great. We got a question from Eric. What about installing a ladder under 24 feet? Can a cage be used, or does this need the fall arrest system?
Any ladder over 24 feet doesn't need a fall arrest system. Cage doesn't. You wouldn't want to put a cage on it either.
Got it. All right, I think we got time for one more question here. How often is eliminating the hazard really an option?
It's challenging. If you buy a building and you have an HVAC unit on the rooftop, it's going to be incredibly expensive to move that HVAC unit off the rooftop. Really, I think where eliminating the hazard comes into play most often is in the planning phase. So when we talk to architects and engineers, we're kind of stressing, hey, let's not try to design a fall arrest system. Let's try to eliminate the components on the rooftop or things in this area work in this area so we can put it to ground floor. That's a great question, but mostly challenge, especially in the construction industry, we're just going to be dealing with what we're dealt with, and most businesses are just we got to deal with what we got, and that's going to be a lot less expensive than actually changing piping, changing structures.
Perfect. And then there's a handful of other questions, but Michael or someone will reach out directly. So
Awesome. I really appreciate everyone coming out for this. This was really fun. Again, if you have questions, Colton's on our team. You can reach out to me directly. QR code again on the last screen here. So connect with me, shoot me an email, shoot me a text. I'll either answer it for you or I'll put you in touch with the right person. So have a great weekend and a rest of your weekend, and then happy holidays, everyone.